This episode is supported by NatWest, providing ease of mind when it comes to business payments.
NatWest Pay It, the bank's own payment solution, facilitates customer payments in near real time while allowing companies to track live spending. Need to collect payments without customer account numbers or process refunds without holding on to personal details? Pay It has your business covered.
Pay It connects directly with each customer's bank account using an API, which also allows data to be seamlessly and securely passed onto third parties. That means you can provide the best payment experience on the front end while empowering your back-end staff with the info they need for truly data-driven decision-making.
To find out more, visit payitbynatwest.com/ITPro. That's payitbynatwest.com/ITPro. This week, Google announced that it had made a major step forward in quantum computing with its new quantum chip, Willow. The AI and search giant stated that it had successfully completed calculations using its new piece of hardware that would have been previously unthinkable.
In doing so, Google has taken shots at existing supercomputer infrastructure and driven excited chatter on social media, as well as worried posts about how the end of encryption is just around the corner.
But how significant actually is this breakthrough? And what does it mean for the future of quantum computing? You're listening to the IT Pro podcast. Hi, I'm Jane McCallion.
And I'm Rory Bathgate.
And today we're exploring Google's Willow announcement to try and wrap our heads around what it means for the future of the tech sector. So, Rory, let's first of all go over what Google has actually announced.
This came as a bit of a surprise. Google has also used this week to make some major AI announcements. So we definitely weren't expecting anything from the kind of quantum side of Google's research team. What they've actually announced is a new chip called Willow, which Google claims massively reduces the amount of errors that you see in quantum computing. And we'll go into a little bit of detail about that later on in the episode. But in essence, Google claims to have completed a very difficult calculation, and specifically a calculation that for a traditional computer is incredibly difficult, and for a quantum computer is kind of fairly simplistic, to demonstrate that they have made great strides in their quantum computing division.
And as I understand it as well, one of the significant factors here is that traditionally it's thought that the more qubits, so normal computers, even abnormal computers like supercomputers, traditional ones, it's bits and bytes. Quantum computers use qubits instead, which are quantum units or quantum bits. And normally, the more qubits you have, the greater the error rate, which seems counterintuitive, or the greater kind of your margin for error. Seems counterintuitive, but that is how things have been. That's sort of been the law of quantum computing until now, a major hurdle to the use of quantum. But with Willow, what they have found is that they are able to scale and increase the number of qubits being used while simultaneously reducing the number of errors. So this is kind of the big breakthrough, I guess.
Yeah, I think it's definitely generated a lot of excitement. I know that Sundar Pichai put a post out on X, sort of celebrating the breakthrough. I think what got a lot of people excited and surprised is this kind of reversal of that trend you were talking about. Quantum physicists and those working in quantum computing have been trying to overcome this: the more complex we make a chip, or the more complex we make a quantum computer, rather, the worse it gets, the less accurate, the more prone to errors. Obviously, that is not ideal when you are looking to create a quantum computer that can actually do anything and is useful for anything. So as a demonstrator, as a kind of scientific demonstrator that, okay, that rule is not hard and fast, we can overcome it, we can one day make very complex quantum systems, it's definitely a cause for celebration.
And in terms of what it's achieved, as well as the reduced error rate, Google in particular highlighted Frontier. So Frontier is Google directly drew a comparison with Frontier. Now, we've spoken about Frontier on the podcast previously. It is
Mm.
currently the fastest, most powerful supercomputer in the world. And what the researchers at Google are claiming is that Willow completed a calculation that would have taken Frontier 10 septillion years, which is 10 to the power of 25, or 10,000 years, which is longer than the universe has been around.
Yeah, this is a serious improvement. You can confidently say that. Um, I think this is there's the aspect of quantum computing where beyond a certain point you really have to understand it to see the benefits.
Yes.
This is a great kind of benchmark for, okay, we're talking about a completely different kind of computer here. We are fundamentally
Mm.
talking about operating not just at speeds that are hard to imagine, but in a method which allows us to simulate, calculate things that traditional hardware, let alone, oh, it's difficult for it to do, it's just not feasible that you could ever do these kind of calculations or even simulations on that hardware.
So I think it's worth taking a step back for a second to talk about how it's possible that this computation, this calculation that would have taken the most powerful computer that we have 10 septillion years to complete was completed in a reasonable amount of time using a quantum chip. So, what the researchers are claiming is if you think about how a standard supercomputer works, it uses parallel processing. So, this is one of the reasons that NVIDIA GPUs helped overcome Moore's law, because you can basically, it's like having a team working on things all at the same time. You will get there quicker if you have lots of resources working on the one same thing versus linear computing where it's just the one chip doing calculation after calculation after calculation to try and come up with an answer. What the researchers at Google are saying is that the quantum chip is computing in parallel with parallel dimensions or parallel universes. Quantum ultimately, and I'm not a quantum physicist, my understanding of how quantum dynamics works is rudimentary at best. But quantum physics introduces concepts such as quantum entanglement, where particles kind of follow each other, for want of a better word, that they are at some level attached to each other. It deals with things like what the thought experiment about Schrodinger's cat is, that until observed, a particle can be in two places at once or in two states at once. This is particularly important for things like the fact that light can be both a wave and a particle. It's when you observe it that you collapse the waveform and it's there in one place in one state. What this chip is relying on is some of that weirdness of quantum physics, to be quite frank about it, and say, okay, yeah, well, we see your chips computing in parallel to come up with an answer faster, than it would take a normal computer doing linear computing, and we raise you parallel computing in parallel universes. What they've said to quote the blog is that, quote, it lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch. So yeah, this beyond computing, this does have some exciting implications if you're into that kind of thing. And from my layperson's point of view, means that we have an intimation that if there are parallel universes, they can actually interact with each other. So very exciting stuff on that. This episode is brought to you by Cloudways, a managed hosting platform built to deliver the speed, simplicity, and reliability your business needs. Cloudways partners with industry-leading cloud providers like AWS, Google Cloud, and DigitalOcean to offer you flexibility and customizability. Cloudways knows that reliable website speeds can make or break visitor interactions. To find out more about how it's helped customers with user retention, download their white paper, The Impact of the 2-Second Rule.
Enjoy a seamless experience where your sites perform at their best, whether you're launching an e-commerce store or handling multiple client projects. Head to cloudways.com to discover how they can power your next big project.
Let's bring ourselves back from the realms of multiverses and how quantum physics works to talk about what this actually means for everybody, for the average Joe. What does it mean in terms of hardware performance, if anything at all, to be honest?
Yeah, I think there's been some division in the reactions, especially online among those in computing spaces and those in quantum spaces, in talking about how practical these results are, what it actually says about how much closer we are to using quantum computers. Um, some have praised it for being a good demonstration of error reduction.
Mm.
I also am not a quantum physicist. Jane, you have a firmer grasp on it than I do, I think. But as far as I understand it, because qubits can interact with one another in a way that traditional particles do not, and are therefore affected by noise in ways that regular bits are not within a chip, it becomes a very sort of complicated, tricky business to actually reduce error in a quantum chip, because seemingly intrinsic factors in the universe can actually affect the the accuracy of the qubits. It's very complex, and it involves
Yeah.
some incredibly dizzying equations in researching for this episode that you see, and they are kind of very dense and hard to understand. But some have pointed out that what Google has actually achieved is it's an impressive demonstrator, but
Mm.
it's not necessarily proof that we've solved the error problem. It's
Yeah.
it's a good way to scale up. I mean, Google in 2019, Google announced another quantum breakthrough with its chip Sycamore, which was a
Mm.
54 qubit processor, and they'd managed to run some calculations reliably on that. This latest chip, Willow, is 105 qubits, so they have scaled it up. And as Google pointed out, every time you scale up in quantum computing, you massively increase the amount of error. So the
Yeah.
fact that they've managed to scale up and at every stage achieve good results is definitely worth applauding. But whether you can just draw a line on a graph from there, it's obviously far from that simple.
Yeah, and I've just realised that the term that I was stretching for earlier to do with Schrodinger's cat is superposition, not
Mm.
entanglement. Although entanglement is involved if you're doing encryption, but with superposition, whereas we in traditional computing, something is a bit is either a one or a zero. With qubits, they are both until observed. So yeah, you can kind of see how these errors occur if you wait until you observe something to see whether it is a one or a zero. To my mind, and once again, the disclaimer about not being a quantum physicist or a theoretical physicist, you're almost a roll of the dice on whether or not it comes up with the correct answer. And that seems to be the problem, that you introduce more chances for error because you introduce more kind of coin flips almost. So, that aside, let's talk about what Google has said the main benefits are, because this is going to sound terrible, but having blown our minds with, this shows that there could be parallel universes, and we've managed to overcome this problem of the more power you have, the dumber it gets. The apparent use case would basically be to do what supercomputers are doing. It's the classic kind of like, what's it going to be used for? Oh, AI in some slightly nebulous sense, and solving cold fusion and all of these things that you and I have previously said we're very sick of, the 5-year horizon stuff.
Yeah, so it's very Google to point at a problem that you've solved and say, this is great for AI. It reminds me a little bit about in the early days of Bitcoin, the meme you would see on Reddit of people saying this is good for Bitcoin, and I can explain why about any change in the market. Of course, anything that Google does pivots back to AI in some way. It's boasted about being an AI first company, and you're right in that this is kind of a nebulous thing to point to. I mean, any sufficiently powerful computer can be used for AI, but the actual practicalities of what that means, if you're looking for an enterprise use case of a quantum AI computer, that's, as far as I'm concerned, massive speculation at
Yeah.
this stage.
I think also when you look at what the problems are with generative AI, some of the issues that it's going to face, it's not necessarily computing power. That's not the barrier or the hurdle. It's training data that there just isn't enough data. And so you can only make small incremental steps. Increasingly, that is the problem. So
Yeah.
having a quantum computer that can carry out calculations in parallel universes is not going to solve the problem of there is only so much available in the various languages of the world for your AI to be trained on, unless we start training on the parallel versions of all the languages that we have in the parallel universes, and I'm not sure that that will be entirely helpful anyway.
Yeah, so I think beyond the potentially uh, science fiction aspects of it, it's interesting. Google's division for quantum is called Google Quantum AI. They are paired in the division name. It's headed up by its founder and lead, Harmet Nevin, and he's the one who wrote this blog post announcing that Willow had actually, they'd made this breakthrough with Willow, and right at the end of the blog post, Nevin specifically says these are beneficial, these are complementary technologies. That's why I named the lab Quantum AI. I'm going to be a bit cynical here and say the reason you named it Quantum AI is probably more that AI draws money, quantum draws
Hmm.
money. You founded it 12 years ago. At that stage, bit of a coin toss to see which would be the more attractive proposition.
Yeah.
At this stage, it's AI. So, put AI in any title, and maybe it's more of it's a better funding round,
Mm.
particularly for something that isn't actually delivering usable results yet. But what he suggests here is that quantum computers could be used to collect training data that you can't currently with classical machines, but doesn't necessarily go into more detail than that. I think
It does sound like they're going to get it from the multiverse. I was joking. I was
the
joking.
collation mission. So what he does point to, and this is a genuine good use for quantum computers, is really complex simulations. And when people think of complex simulations, you might think of the kind of thing that the newest most powerful supercomputer in the world, El Capitan, is doing. That's simulating nuclear detonations and looking at nuclear decay and looking at the US's nuclear arsenal. But actually, if you're looking at a quantum level, really anything in the world is very complex. There are infinitesimal processes going on. So he points to things like, well, nuclear fusion, very complex, but also medicines, looking at designing more efficient batteries for electric cars. These are things, batteries and drug discovery is something that, yes, we've been doing that for a century. On the other hand, when you get to things like, for example, I know that, I mean, he didn't point to this in the blog, but I know that, for example, renewable energies, solar panels, there is an ongoing sort of research battle to be the one to crack perovskite tandem solar panels, which would allow you to potentially use at the upper levels moonlight as a source of energy, or even
Oh.
much 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 more efficient solar panels. And something like a quantum computer maybe could be helpful for discovering the right chemical formulas for that, and the right cracking the physics for putting that into production.
Hmm.
But then again, we circle back around to this all being speculative.
Yeah.
It's we're at a crossroads, and we're so early on in this technology still that any potential thing it could be used for is being pointed as a thing that it will be used for, but we don't know that yet.
Yeah.
So the other kind of social media post we've seen around this is the panicky one, the one that suggests that this essentially moves the clock closer to midnight, if you will allow the doomsday clock imagery, that we are now one step closer to having to replace all of our encryption. Jane, I wonder if you could explain kind of where these fears come from. And I know this is something we've spoken about on the podcast before, but what threat does quantum actually pose to encryption?
Yeah, so this is what I was talking about earlier with regards to quantum entanglement. The idea is that with quantum computing, you might have better encryption through quantum entanglement with the fact that you've got these two particles, and if you alter one or other of them, they should come out the same at the end of a process, and that will show that they haven't been tampered with. If they don't, then something has gone wrong. With quantum computing like this, when it comes to traditional encryption, basically you're relying on having a formula, for want of a better way of putting it, that is unbreakable using linear computing, or even supercomputers might struggle. With quantum, the idea is that it would be able to solve this, and problems such as P versus NP, which is a fairly famous mathematical problem, where P versus NP has currently not been proven one way or the other. And the question is P the same as NP, in which case all encryption is broken, and if it's not, then it's not. Quantum could solve P versus NP, which could potentially break all encryption, and obviously it could solve these calculations faster. We will definitely put some links in the show notes for that, because I'm not explaining it particularly well. All that said, you'd have to get your hands on a quantum computer
Yeah.
first. So yeah, in theory, yes, but in practice, probably no. And as I say, to my knowledge, it depends on the outcome of P versus NP. Anyway, if P equals NP, then it's broken. If P does not, then it's not.
Mm. Yeah, I think a lot of the panicky posts I've seen have been quoted, or in the replies you've seen people say, "Okay, but we're not there yet."
Yeah,
That's what all of these. We've seen a lot of standards being now pushed by security regulators saying, "Okay, banks, okay, governments, everyone really get your post quantum encryption standards in place. Let's begin that discussion now." Because even the developers of quantum computers are saying, yeah, it's just around the corner. And when you ask when that is, they say it's 2035, maybe. So,
yeah.
okay,
Five
good. That's a
years,
good,
10 years.
yeah, it's just around the corner. It's jam tomorrow, as with fusion power, which is why I find it funny that it says that it can be useful for fusion power, because why not? Um, but yeah, we're not there yet. Like we said, this is not coming out tomorrow. It's a good demonstrator, but as far as Google specifically, kind of pushing us closer to this, it's pushed us as close as any advance in quantum computing has. It's a good project to have accomplished, and
Mhm,
Google, in the blog post says that it's now working on more practical applications. It's looking at demonstrating qubits being used for something that businesses or customers can say, oh, I can imagine that applying to my field, rather than
mhm.
just a theoretical thing. And maybe when we get there, we can start panicking, but we're not there yet.
Unfortunately, that's all we have time for today, but as always, you can find links to all of the topics we've spoken about in the show notes, and even more on our website at itpro.com.
You can also follow us on LinkedIn, as well as subscribe to our daily newsletter. Don't forget to subscribe to the IT Pro podcast wherever you find podcasts. And if you're enjoying the show, let us know by leaving a rating or a review.
We'll be back next week with more from the world of IT. But until then, goodbye.
Goodbye. This episode is supported by NatWest, providing ease of mind when it comes to business payments.
NatWest Payit, the bank's own payment solution, facilitates customer payments in near real time while allowing companies to track live spending. Need to collect payments without customer account numbers or process refunds without holding on to personal details? Payit has your business covered.
Payit connects directly with each customer's bank account using an API, which also allows data to be seamlessly and securely passed onto third parties. That means you can provide the best payment experience on the front end while empowering your back-end staff with the info they need for truly data-driven decision-making.
To find out more, visit payitbynatwest.com/ITpro. That's payitbynatwest.com/ITpro.